Okay, so since we're moving in a circular motion, this distance is going to be replaced with arc length. And you learn this in geometry, and it is so okay if you don't remember it. This S is radius times radians. Now you might see some formulas with the letter S. I don't use that. I use R times theta. It means the same thing. S, there's just too many letters. I get confused. I know exactly what that is. I might forget what S is. Because S to me sounds like it should be speed. But that's why I remember this. T, of course, that's pretty basic. We know that's time. V is the linear speed, but we're going to call it velocity. So the first equation that you're given, and you're really not going to use this much, looks like this. Linear velocity is going to be radius times radians divided by time. Cool. And then you have this wonderful graphic down here that really doesn't mean too much. It's there for you to review on your own. Let's turn the page. All right, let's talk about angular speed. Remember, angular speed is of the object is the angle measured in radians, swept out divided by the time elapsed. So the second equation that's not going to be provided, you do need to get this one done. Look, see how it has that little curvy looking W? That's actually a Greek symbol. So let's draw a curvy looking W. I wish I remembered what that was. I don't. That angular speed equals radians divided by time. But you got to remember when you took notes on graph paper, we talked about rotations. Remember, whatever the rotation was, we multiplied, don't write this down, we multiplied by 360 to get the degrees, but we're just dealing with radians. How many radians on the unit circle is 360 degrees? 2 pi, good. So we're going to take rotation and we're going to multiply it by 2 pi. All right, and if any of y'all are in auto tech, so applicable to auto tech speed. All right, so angular speed is the way of turning. Angular speed is the way the turning rate of an engine is described. Okay, so an engine idling at 900 revolutions per minute is one that rotates at an angular speed of, let's figure that out. All right, so the first thing we're going to do is we're going to convert the rotation to radians. How many rotations do we have? 900. Let's do 900 times 2 pi. So we have a radians angle measure of 1800 pi. Now, remember to find angular speed. Now we're going to use our little formula. You just divide by time. So angular speed is going to be 1800 pi per minute. So let's talk about that. See that pi symbol? What's the number for pi? You don't know. I don't know either because it never stops, right? So this is exact form. You know I'm going to be asking you for exact form. It's in terms of pi. Let's go ahead and convert it. Let's round. Y'all, there's a pi key on the pretty pink calculator. Y'all see it on the left? Let's do 1800 times pi. Look, as soon as I hit enter, it's rounded. That's exact form. Enter. Now it's not exact form. So how many radians is it changing per minute? It is changing approximately 5,654 radians per minute. That's how much it's changing per minute. So that's our little rounded answer. So I'm going to write W with a approximate sign. And that is 5654. Let's just round to the nearest whole number. 5655 radians per minute. Okay. All right, so let's look at this part. This is the part you're going to use the most. There is an important relationship between linear velocity and angular speed. Now remember, linear speed, we use v for velocity. Remember, it was r times theta over time. And remember, angular speed, it's off my screen, but it's up there where equation 2 is. Angular speed was our fun little curvy w, and it was pi over time. Now look. Theta over time. Theta over time. So the easiest equation that you and I are going to use is velocity is radius times angular velocity. That's the one we're going to use the most. So, if I'm running in a circle, I'm running around a circle. If I'm running a perfect circle around this room, if I want to know how fast I'm going, I would define angular speed and just multiply it by the radius. Boom. That's linear speed. That's the measurement we're familiar with the most. Let's look at this. This is talking about measurements. And that is for your reading enjoyment. I'm just going to go ahead and show you what those words mean. Let's turn the page. And let's start working through this stuff. Okay, so a child is spinning a rock at the end of a 2-foot rope at the rate of 180 revolutions per minute. So swinging a rope, it's going to make a circular motion. Find the linear speed of the rock when it is released. The instant that kid lets go is going to be the velocity of linear speed, because the instant you stop, it has completed a circle. All right, so let's talk about our steps for linear speed. Convert rotations to radians. Number 2, find angular speed. Number 3, multiply by radius. And remember that paragraph that was for your reading enjoyment? That was about measurements. So multiply by radius with measurement. With measure, I'll just write with measure. Okay, what is she talking about? Let me show you. Okay, convert rotations to radians. So it's traveling at a rate of 180 revolutions per minute. So revolution is the same thing as rotation. So 180 times 2 pi is 360 pi. So that's your theta. Find angular speed. Okay. So it's going to be your theta, which is 360 pi divided by the time elapsed. It's just 1 minute. Done. Step 3, multiply it by the radius. So linear velocity is going to be 360 pi over 1 minute times the radius. What is the radius? 2. And we need to write the word feet. So how fast is that rock traveling? It's traveling this fast. Let me show you. It's traveling 2 times 360. It's traveling 720 pi feet per minute. What is that? That's exact form. How do you know? Because there's a pi symbol. I have no idea how fast that is. If I ask you how fast you run and you say 720 feet pi per minute, I have no idea what that is. So let's go ahead and find our rounded answer. Let's do 720 times pi. So how fast is that rock traveling? 2261, or let's just round it, 2,262 feet per minute. 2,262 feet per minute. That's rounded. I cannot use these. I love them, but I can't use them with those. All right, let's look at example number 2. The radius of each wheel of a car is 15 inches. If the wheels are turning at a rate of 3 revolutions per second, how fast is the car moving? Who drives? Like to here? Okay. How fast can you go on Katieland? What's that speed? Say that again. 30. They will get you if you go over 30. 30 what? Miles per hour. So, y'all, we're going to take this from inches and seconds to miles per hour, because that's what we record automotive speed here in the U.S. All right, and that conversion is all going to happen on my calculator, so make sure you pay attention on that. Okay, but first, our little steps up here. Number 1, it is 3 revolutions, so 3 times 2 pi. So we know theta is going to be 6 pi. All right, angular speed. Angular speed is going to be 6 pi per second. Okay, let's find the velocity. That's going to be 6 pi per second times the radius of 15 inches. So the speed, the exact speed, is, let's see, 15 times 6. Go ahead and multiply those numbers together. So that's going to be 90 pi inches per second. So if I get pulled over on Katieland, you know, the cop's going to say, how fast do you think you were going? I cannot say, 90 pi inches per second, because then I'll for sure get a ticket, because he knows I'm just being a smart aleck. So let's convert it. I don't know, he or she may be impressed. Who knows? All right, it is all calculator work. I'm even moving this packet. Clear, clear, clear. All right, 90 pi. Enter. All right. Pi symbol's gone. What does that mean? That means that car is traveling 282 point something inches per second. Let's start getting rid of the inches. How many feet, or how many inches are in a foot? 12. So if that's 282 point something inches, what am I going to do on the calculator to turn it to feet? Yeah, let's hit divide by 12. All right, cool, here we go. So how fast is that car traveling? 23 point feet per second. 23 point something feet per second. But we want it in miles. Who knows how many feet are in miles? Raise your hand, don't say it out loud. That's what I thought. I've had one person all day long know that. Y'all need to know that. That's a life skill. That is a life skill. We're all going to write this down at the top of our paper. You ready? This big, right? 5, 2, 8, 0 feet equals 1 mile. Seriously, y'all do need to know that. Not just because I'm a math teacher. That's life hack. Okay. So, if I have 23 feet, how would I convert that to approximate miles? Divide. Got that little portion, so let's hit divide. 5280, and I get that 0.004 something. So, I go 0.004 something miles per what? Second. We're in seconds. Now we got to fix that. Let's convert it to minutes. How many seconds are in a minute? So what do? It's that second. Multiply by 60. Okay, we're almost there. I go 0.26 miles per minute. What do I do to get it to hours? Yeah, times 60. One more, multiply by 60. There we go. How fast is that car traveling? 16 miles per hour. And we're going to round to the nearest whole mile because that's how we're used to seeing speed. Good job. Look, if you don't have this memorized, that's going to trip you up and get you the wrong answer. You have to memorize that. I'm not giving any formulas at all. Okay, so the speed, we rounded 16 miles per hour. Any questions on that? All right, let's do it again. Hold on a moment. Yeah, let's do it again. This is the only one where the time was not a single unit of measure. So let's for sure talk about this. A neighborhood carnival has a Ferris wheel whose radius is 30 feet. You measure the time it takes for one revolution to be 70 seconds. What is the linear speed in feet per second and angular speed in radians per second? Let's go ahead and knock out this revolution. So it's one revolution. 1 times 2 pi is 2 pi. So that's our radians. Let's divide it by the time elapsed. How much time was it? Yeah. Okay, that's your angular speed. Look, if you put that as exact answer, it would be right. Look at 2 over 70. Can you simplify 2 over 70 as a fraction? Yeah, you got to simplify it. So my exact form for angular speed is pi over 35 seconds. All right, let's find angular speed. Okay, let's just multiply that by the radius. What is the radius? 30 feet. So, times 30 feet. So, velocity is going to be 30 pi over 35 seconds. And of course, if I asked for exact, that would not be right. Y'all can simplify 30 over 35. Excuse me. What's 30 over 35 simplified to? Yeah, I know. Let's write 6 pi over 7 seconds. 6 pi inches. Actually, hold on, I'll show you. That inches is going to go on. Oh, feet. is on the top. So we go 6 pi feet for every second. 7 seconds. And that's ugly, but that's the exact answer on that. Our work is good. There's your linear speed. Here's your angular speed. Okay, we're going to do one more. Just one more. Turn your page. All right. Guys, you don't have to do that bottom problem. Let's look at the top, though. To approximate the speed of the current of a river, a circular paddle wheel with a radius of 4 feet is lowered into the water. If the current causes the wheel to rotate at a speed of 10 revolutions per minute, what is the speed of the current? We are going to analyze the speed in miles per hour. So you have one more chance to practice that conversion on your calculator. All right, let's go ahead and get started here. So the revolutions are 10. So theta is going to be 20 pi. Angular speed is going to be 20 pi per minute. Linear speed is going to be 20 pi per minute times the radius, which is 4 feet. So linear speed, exact linear speed is 80 pi feet per minute. That's exact. Convert it. See if you can do it.